Let's introduce some background concept. First, cardiovascular disease, such as CVD. Cardiovascular disease is a worldwide epidemiology. It's a very common chronic disease, and the population who got CVD has increased dramatically in recent years. The population who died because of CVD has increased from 14 million in 1990 to 70 million in 2005. The World Health Organization estimates there will be about 20 million CVD deaths in 2015. And also, researchers also says that the CVD will account for more than three-quarters of the deaths worldwide by 2030, and CVD alone will be responsible for more deaths comparing with other very popular disease like infectious disease, mental, mental and parental conditions, and nutrition disorders and other diseases. So CVD is today the largest contributor to global mortality and will continue to dominate mortality rate in the future. Uh, Electrocardiogram, short as ECG, is the basic method detecting cardiovascular disease in current medical technology. The traditional way of detecting CVD is to print out the electrocardial signals, and then doctors will calculate each kinds of electrocardial parameters based on the printed out electrocardial signals. And these electrocardial parameters includes the attributes of all kinds of waves in listed in presented in the electrocardial signals. Then doctors will analyze all the parameters to make further decision. While for electronical detecting, the most obvious characteristic is to recording all the cardio information for a relatively long period of time. So this causes another problem, that so much information a doctor so that doctor can't analyze by their own. In this way, um, electrocardial signal analysis takes too much time and effort, and it takes a relatively a long period of time. So ECG analysis not only can help doctors diagnose the disease more accurate, but also save doctors from massive cardio information. That's why we design this software. And as mentioned in the background part, doctors have to analyze a lot of electrocardial signals to get further medical decision, and the more information they got, the more accurate the final result they will get. And dynamic electrocardiogram is to monitoring and recording patients' ECG information 24 hours around. Regards to the problem that sudden heart attack that patient might get, so patient can't lie on bed for such a long time recording. So based on this healthcare and problem, this software is mainly about offering users dynamic electrocardiogram. Um, the soft demanding analysis is divided into two parts. functional requirements and non-functional requirements. The functional requirements part including user management, data search, and ECG wave analysis, and instant cardio monitoring. User management. Software working needs a current user. Without user information at its initial use, it should offer new user to create an account. Needed information include name, sex, age, and emergent contact. Emergent contact is used for when people got emergent situation like a heart attack. They can use this software to automatically call the emergent contact for help. And during its runtime, the software recognizes a current main user. Once it's not initial application, software treats a last time user as its main user by default. And besides, in the user management page, software also includes other functions like user information edit, delete user, and switch user. Data search. Considering general Android platform-based medical terminal device, it has limitations because of the size of screen, so it's not a good idea to display all whole ECG wave together with its analysis together on the screen. In this way, data will be displayed in three parts: ECG wave, abnormal wave, and analysis results. ECG wave is about displaying all the electrocardiogram image. User can choose to display the whole wave in a selected period of time, and can zoom in, zoom out, or move the wave to look at it clearly. Abnormal wave display is similar with ECG wave. It also needs to function for user to move, zoom in, and zoom out the wave. This part is more about to select a part of the wave that is not normal based on stored information and initial analysis. This period of wave have medical significance and need to be further analysis by doctor. Analysis result displayed is this part display the stored file that user selected. After a little research and analysis, software will display all it can be found at initial application. User can log in the account and select corresponding folder, and then select then look at the corresponding information they need. And then it's about ECG wave analysis. ECG wave analysis is the key function of this software, and the main purpose of designing this software is to get an initial diagnosis based on ECG wave and offer some medical advice based on analysis results. Those results include average rhythm of the heart beat, average wave of QRS wave, cumulative times of premature ventricular contraction, and category of arrhythmia. This part is not that complicated to realize. It's mainly about two parts. It's about realizing the arithmetic and the invocation of arithmetic. In this way, arithmetic design is mainly is the key part. Indexing cardio signal characteristic points is about to find cardio signal characteristic points, including locate R wave, start of Q wave, and end of S wave. So this is the key part of the analysis. We have to choose the right uh, arithmetic to get a most accurate result in the fastest time. And instant cardio monitoring. Because of lack of data collection hardware, all the data comes from MIT BIH. So we use data from MIT BIH to do simulation. After user selected information folder, we process a mock data collection and then display analysis results on screen, including current rhythm of heart, cumulated times of premature ventricular contraction, marker of missed beat, and marker of stopped beat. In addition, once a new user logged in, there's no history record, so there's no corresponding folder. Software will offer users some folder sample from MIT BIH to select. Once user use a certain sample folder to do ECG monitoring, every information should be saved as measurement record. And non-functional requirements. Based on the summary of content of software practice and the instant reflection of requirements, this software should be reasonable designed and avoid consuming too much time on main page threads. Regarding to the analysis and monitoring part, analysis speed of arithmetic decided how fast the analysis result can be shown on screen. So arithmetic characteristics should be considered when choosing from different arithmetic. As an Android application, if the main page thread didn't respond in 5 seconds, system will notice user whether close the program or not. Although we considered this and put new analysis process into new thread, regards to user's experience and other aspects, the time spent on analysis could not be too long. Data in MIT BIH took 30 minutes at most. We may make different time requirements for 10 minutes, 20 minutes, 30 minutes data.